Hello, this is a partial teardown, a lubrication, and a check of an Akai CR80DSS quad 8-track player. So this particular unit I purchased on eBay because I really wanted to listen to Dark Side of the Moon in quad. And this particular deck was something that, people online said, yeah, this was one of the best, if not the best decks that was out there. So luckily, I went looking, couldn't find anything, suddenly found this. There it was, bought it, and it was a cream puff. So you can tell from looking at the front panel, this has been a very clean unit, non-smoker. You're seeing the inside of this unit as it was received from the seller. It's extremely clean. Everything looks really good. There's no discoloration. There's no light damage. A lot of times people have these in their homes and the windows, they'll leave the windows open, it'll shine in. You'll see a lot of fading, a discoloration on all of the pigmented silk screening, a lot of yellowing in the lens, a lot of paint, and also the clear coat over the aluminum. A lot of times that'll yellow. And like the lettering on the buttons will also be yellowed. So again, that comes from smoking, it comes from UV exposure and just age, and people just generally take care of their stuff. Luckily, this one is in fabulous condition. In fact, I'm wondering whether or not this was really ever even played because it has such little, signs of any kind of wear. Normally inside on a lot of the components, the mechanical parts inside, what you'll see, I'll show you on this solenoid, there's plating and you'll see normally wear from this washer on these plungers and all mechanical parts. I don't see any patterns of wear on here. So it's quite possible that this unit was purchased and it was just put aside or never even unboxed. And another clue about this particular unit is on the back panel, notice that, and I just noticed this a little bit late when I was looking at it, but this apparently is a calibration and check label from the factory, from the Akai, and you can tell by sort of the characters and the way that they wrote this, because I used to work in the electronics business and automotive, and that's when we would get things from Japanese engineers, this is how they would write English. And so this is from the factory, and note the date, 10/4/78. Quads came into the mainstream probably about 1973 and 1974, 75. That was the peak years for quad. Then the quad kind of just faded away sometime probably 76. So this is kind of a late production for quad in general. I don't know the particular history of these Akai quad decks, but this is fairly late, and that's important for a couple of different reasons. The first of all is the capacitors in these units, and I'll talk about that in a second. I want to go to the top of this unit. So this is the top side. There's a lot of, or mostly power and electromechanical and wiring and connectors on here. You don't see a lot of the guts of the electronics on the other side, which we'll show in a second. But in general, I wanted to point out a couple of things on this unit. And it was new to me. I'd never seen one of these. But I was an electronic tech. I'm an engineer. I've been doing this for decades, like 43 years of doing this. So plenty of experience doing with this vintage equipment. So there's nothing topside here except for there's one electromechanical component that had any kind of lubrication and grease on it. And this was one of and I'm not even sure what the function of this particular switch is, but you can see that this now has kind of a clear grease on it. It's not a heavy grease. When I originally got the unit, it looked like glue. So all the grease that they had applied to these units and all the lubrication points had completely dried up, and it was just like glue. It wasn't even going to move. So we're going to start on that, talking about these lubrication points. There's only a few of them, and there's one thing I'll show as we get further in that's going to be critical to the functioning of these decks, but I just want to illustrate the technique. I got a little container of lacquer thinner over here. It's a little jar, and it's a small, stiff artist. It's this very stiff bristle brush. It's very stiff. It's not very compliant. This is going to be critical for two different things that we do to these units. And the first one would be get in here with the lacquer thinner. You can't use alcohol because it's not aggressive enough, so you have to use lacquer thinner. It's kind of much a must. But you got to get this grease out. Dried up grease is I have all kinds of electronics from the 50s, 60s, 70s, and it's the bane of any kind of electromechanics. I guarantee you, if it's seen any use or if it's been in service for any amount of time, that grease will be dried up and it will cause you problems. So you have to get it out. What I use on these units in the very few lubrication points that are existing on this thing is this stuff. It's called Kluber Isoflex. Now, this isn't something you're going to get at Home Depot. You have to mail order it. What this is called high-speed spindle long-term grease. It's spindle grease for high-speed milling machines. This goes in bearings that turn 20, 30, 40,000 RPMs. And so this stuff has got very low viscosity and it won't dry up. And that's crucial to any kind of speed control mechanisms, motors, and all these solenoids and brackets in here, because you don't want any drag on it because it won't work. So anyway, so that once this was cleaned, we applied a little bit of thin layer of that Isoflex to this lubrication point. And don't go nuts. Don't go in here. If there's no lubrication on it, don't put any on it, because a lot of the stuff is not designed to have any lubrication on it at all from the factory. So don't go putting it there because you'll be sad. Next lubrication point is these two guys right here. This is the flywheel, and this is the spindle. So all this is a metal shaft. Underneath I've already done this, but pull the pulley off. There's a bronze bushing, and you put a little bit of light machine oil. I will show you what I used. This is from GC. This is very old, but it's very lightweight machine oil. It won't get gummy and it won't dry up. So that's almost like clock oil. That's something that you need to lubricate these plain bearings and bushings. You got to go sparse, just a couple of drops, to make sure that when this is in operation on this top bushing, that it doesn't drain down into the spindle and get onto the tape, because again, it's just going to slip. It's going to cause you all kinds of trouble. So a couple drops here, put it back together. This is the motor. So in here, there's also a plain bearing. I think they did that to minimize rumble and just chattering and stuff, but they're all plain bushings, same treatment. You don't have to worry as much about this because there's just the motor, but don't overdo it. A couple drops in here, put the pulley back on. Here's another kicker in these tape decks. This is the belt. Now, if you notice, this particular belt is really thick. I was kind of surprised by that. Normally, they're a lot thinner than this. So Akai did a great job, and they used really good rubber, because this particular belt has zero signs of chalking or oxidization or crazing or cracking on it. I mean, it is in perfect shape. On this one, I used isopropyl alcohol. Wasn't getting any residue off. Normally, if a belt is starting to deteriorate or stretch, you'll get a lot of black residue off the belt, even though it hasn't been run. So that's kind of an indication that the belt itself is not really the best, and you might want to be looking for a replacement. I don't know if you can get these anymore. Thank God this one was okay. I did, and this is something that people will argue about. I always take, and this is from a long time ago, take a little bit of lacquer thinner just to get the Q-tip moist and run it along just the inside. It tends to restore and pull off some of that surface oxidization. It'll make the rubber supple. Don't go crazy. So people say it degrades rubber. I've never seen it. So if you get a belt that may be slipping, you can usually do a Hail Mary on there and put a little bit of lacquer thinner on while you just spin this like this and run the Q-tip on the inside, and you'll rotate it and you'll pick up a lot of black stuff, and you'll keep doing that because it'll keep taking the rubber off. So that's a trick that you can use to sometimes bring a belt back if you're seeing wow and flutter and slipping on the, assuming it's not slipping on the tape, that it's actually the belt slipping. So that's it, I think, for the top side. I want to talk about a couple of things while I'm in here. Capacitors. So any kind of old electronics, it's a crapshoot. There are sometimes you get lucky, like this unit. The capacitors are perfect. There's no problems with them. They measure just like a brand new one. What I did, there's a multi-section electrolytic here. There's a larger one here. And if you look at the construction, this looks like a brand new one. I mean, in terms of the construction style, I think it's a Nichicon. These are all apparently really good capacitors. So it looks like the guys at Akai went and bought the good stuff. They didn't buy the cheap crap that was there putting out of these other plants. Typically, you'll see they fall into two camps. You'll get manufacturers like Cornell Dubilier or Mallory and Nichicon. They make really good units. 40, 50 years later, they're fine. You will get other ones, and I'll show you. This one came out of a 1968 Galaxy Electronics ham radio. Note that Whale 51, that's a name you can count on right there, right? 1,000 microfarads, 20 volts. It was a 500K resistor, almost no capacitance at all, was not working. So you got to be really careful. And it seems like sometimes the further you go back on the Japanese stuff, the worse the caps are. So luckily by late 70s, which is why that build date's important, caps, they seem to have solved the problem, and Akai used good stuff. And I did check that cap right there, pulled it out of circuit, measured it, dead nuts on. 3.3 mics, every resistance, everything looked good. So at this point, I'm not taking any more chances. I'm not going to, risk destroying anything or breaking a trace or doing anything. I'm going to leave the caps in there. Based on the few measurements that I did, I think this unit's fine. So.
How did you measure the capacitance while it was in circuit?
I didn't. I took it out of circuit and measured it with the LCR meter. That'll usually tell you what the capacitance is, and then I use the Agilent DVM to measure the static resistance there, and it looked just like a brand new one. So at that point I said, well, they're probably good, unless there's we go back in during the subsequent part of this during listening tests and I see some issues on the channels, I'm not going to touch it. So first, do no harm. You don't want to go nuts on this. But again, look at the caps, pull a few out, measure them out of circuit. If they're all good, chances all the rest of them are good too. So that's been my experience. While we're in here, I'm trying to see if there's, oh yeah. So take a look at this board. I want you to do a close-up on that. If you can see that. If you can see, what looks like pancake syrup on this thing. Looks like somebody went to Waffle House and had an accident on this board. That's flux. I've been getting a lot of problems with flux contamination and shorting on high impedance circuits lately. It's a little tough to see. You got to kind of vary the light, but you'll see this. It's glossy. It looks like pancake syrup. It's exactly what it looks like. It's been dried up. So that flux, back in the day when they did all this hand soldering, they didn't go back and use flux remover. They just soldered it and put the boards in and shipped it out the door, which is great in 1978. But fast forwards now, especially like if stuff gets humidity in it, it'll start to break down. It'll have a high impedance path between these nodes on these boards.
It's really hard to see.
Yeah, it is hard to see. You might have to shoot from the side. If you shoot from this side, you can probably see it. It's a little difficult to see, but it's pretty obvious when you see the board. You might be able to look at this one as well. But if you've ever done electronics,
that one's easier to see.
Yeah, you know what flux looks like, so it's there, and there's a lot of it. They really didn't skimp on that. They put a lot of flux on these boards. This stuff's all switches and power and stuff like that. So even if it's, let's say maybe it's a meg or it's a couple hundred K on a couple nodes, probably not going to affect anything for now. So I'm leaving some of this because it is really difficult to get off. And I mean, it will take, I've been doing this for a long time. I'm usually pretty good at this. It is a bear. And I'll show you kind of what happens. But expect to do, here's your friend. I use tech spray, flux remover. You can't use alcohol. You can't use lacquer thinner. You have to use flux remover. The other thing is you're probably going to want to go get one of these. I can't remember who makes it. It's from Taiwan. This is some kind of, I've had this forever, but it's a stiff bristle brush. It's very stiff, just like these. You can't use a soft one, and you have to cut it so that give it a crew cut so that it's got some area, but it's stiff as shit because that's really important to get down in here and do. So what you end up doing, I'll demonstrate the technique and I'll show you in a second a before and after. You have to spray very gently, and you sort of modulate the tip to where you get drops out. You don't want to flood it. Just put a few drops on here. You got to work it in, and you got to gently work this flux off. And it's repeat applications. You have to take a paper towel usually, and you use these shop towels. This is another trick of you doing this. It's just, I can't really, stress how important this is and how much of a technique there is. You notice this brush is really clean. You may go and you may do a few passes on this board. You have to take a little container of flux remover, spray it in there, and then dab it out until it comes clean on one of these shop towels. Because what you'll do is you'll put the flux right back onto the board. So Once you get it off, and it's going to come off in layers, dab it, clean it, come back and do that, and eventually, and you have to pay a lot of attention to in between these solder joints. That's where you're going to get a lot of problems, because if you notice, most of the flux is right around the component leads that came into the board. Right around those little joints is very difficult. There's a lot of it on there, and it's going to take a lot of scrubbing, but you will be rewarded eventually, and it'll look really clean. But if you're not a patient person, forget it. I mean, you just have to take a Xanax and go do this, and it's going to take a while. So, any rate, so that is, now again, I'm not, probably, unless there's some kind of a circuit problem, I'm not going to come back and do these power and low impedance nodes, because they probably will never give us any trouble in the lifetime, at least my lifetime. One other thing I forgot to say is there's, Q-tips, Q-tippage. There's these nice wooden, I can tell you what the kinds are. These are your ordinary garden variety Q-tips. These are good for something. I'll show you about that in a minute. These are the wooden ones. These are Chemtronics grade. So it's this pharmaceutical. They're on the wooden stick. This gives you the reach that we're going to need to clean the heads. And so I'll show you. And sometimes you need a really stiff brush to be able to bear down. Where that comes in, if you're just cleaning these from a certain, you don't want to remove the pulleys, you have to dunk it in some lacquer thinner right on the surface of this metal surface of the pulley, and you got to spin the pulley. And what you'll see is you'll start, and this one came up pulling off this grody, kind of a brownish orange residue, and both pulleys there was something on there. I don't know what it was from. It was plating. Eventually it came clean, but you got to get all that stuff off because it'll slip. It becomes real slick. So that's the Q-tips. Try to avoid Q-tips on stuff like this because it leaves pieces of cotton and they'll get jammed. So I don't really recommend that. Just use a brush and some lacquer thinner. And then when you're done, you can usually take, there's the trick on this. These are bendable, right? They take a set so you can come in underneath. A lot of times you can't get in here, and you'll come in underneath and you can clean some of the grease. There's some left on here, but some of the grease underneath that gets stuck in the chunks. These are very nice to be able to get into delicate areas. But again, try to avoid, using this as your main cleaning tool on that stuff.